Black holes, the most strongest and mysterious object in the universe. They are so strong that not even light can escape their gravity. How do black holes have strong gravity? And what even is a black hole? For that question, we need to understand how a black hole forms. A black hole is born when a massive star dies. Stars are incredibly massive collection of hydrogen atoms. Immense pressures and temperatures in the star's core squeeze the nuclei of hydrogen atoms together to form helium. This process is called nuclear fusion. Nuclear fusion releases energy. This energy, in the form of radiation, pushes against gravity, thus maintaining a balance between these two forces. As long as there is fusion in the core, the star remains stable. But for stars that have way more mass than our Sun, they are capable to fuse much heavier elements than helium until they reach iron. Unlike any other elements, the fusion process that creates iron doesn't transfer energy. Iron builds up at the center of the star until it reaches a critical amount, and the balance between radiation and gravity is suddenly broken. This makes the core collapse, and under a fraction of a second, the star implodes, resulting in one of the most amazing events in the universe called supernova. A supernova either produces a neutron star, or, if the star is massive enough, the entire mass of the core collapse into a black hole. This is how black holes are formed. Stars like our Sun is most likely to become a red giant and collapse into a white dwarf. Now, how do black holes have strong gravity? You can consider black holes as a dent, the fabric of space-time. The gravity is so strong because matter has been squeezed into a tiny space. This creates a dent in the fabric of space-time.
Well, supposing that I were to keep on compressing that 4 pounds, smaller and smaller and smaller, it's like a BB. Now it's like a pinpoint. Eventually, I would get a situation where you still have that curvature, but the ball is so small that you can't even see it anymore. And that's really what the idea of a black hole is that the space-time is curved, but the mass that's curving it is so small that you can't even see it.
So this is how black holes attract anything that gets too close to them. Not even light can escape from a black hole's gravity. That's why we can't see anything that went inside of a black hole. NASA has recently captured a real image of a black hole. When you look at the black hole, what you see is the event horizon. Anything that goes beyond the event horizon is gone forever. Once inside the black hole's event horizon, matter will be torn apart into its smallest subatomic components and eventually be squeezed into the singularity, which is the last part of a black hole as we know it. What will happen to the particles that went inside is still a mystery. There are two types of black holes discovered: stellar mass black holes and supermassive black holes. Stellar black holes are much smaller than supermassive black holes. They are also caused by the supernovas of massive stars. Supermassive black holes are extremely huge. They can be found at the center of galaxies. Our own galaxy, the Milky Way, also has a supermassive black hole at its center, known as Sagittarius A star. It has a mass of approximately 4.3 million suns. The gravitational power of these black holes play a significant role in keeping the galaxy together. In fact, it has a good side and, of course, a bad side, just like any other things in the universe. Some scientists suggest that black holes can be used for time traveling. Traveling through time sounds fun, but it can cause a lot of trouble. For example, the time paradox. Well, that's another video. Make sure to subscribe so you won't miss it.